In this video, I'm going to introduce the concept of a Z-score. Now, I'm not sure really why they're called Z-scores. I'm not sure why they chose Z. Really, all these scores are very closely associated with the concept we've just had about standard deviations, and they would have been much more appropriately named standard deviation scores, because you're going to see that the Z-scores are numbers from basically -3 to +3, which you can probably work out. -3 is when you are 3 standard deviations below the mean, and a score that is a plus, has a +3 Z-score, means it's a result that is the mean plus 3 standard deviations. A score that has a result that has a Z-score of 0 means you're spot on the average or the mean. Okay, so formally, each individual result or score has its own Z-score. Now, depending on where it's positioned under our normal distribution, it'll have a positive Z-score or a negative Z-score. And the Z-score is different for each different score. So we're not measuring the size of the standard deviation anymore. No, your calculator does that, and it's one value only for standard deviation. These Z-scores are actual scores. Oh, no, that's not true. Z-score is the relative position of a score from the mean. So it tells us where the score is located compared to the mean. It indicates the number of standard deviations. That's a particular score is located away from the mean. The result that is the same as the mean would have a Z-score of 0. It's 0 distance away. The result, any result or score bigger than the mean has a positive Z-score. A result that is lower than the mean has a negative Z-score. A Z-score is rarely higher than 3 or lower than -3. We saw that. There's a very small percentage in that section of our graph. Scores generally then lie within 3 standard deviations of the mean. In fact, we know exactly 99.7% of scores lie in this range. A Z-score of +2 indicates the score is 2 standard deviations higher than the mean, and a Z-score of -1 indicates that a result is located at 1.5 standard deviations below the mean. This diagram illustrates that beautifully, and you can see why it's so closely connected to the data we've just been looking at in terms of the mean and 1 standard deviation, or 1 standard deviation above the mean, or 1 standard deviation below the mean. So we're giving some direction to the position of a score now. When it's positive, it's obviously above the mean, and when it's a negative, it's below the mean. We still have those same facts about the number of scores that lie between a Z-score of -1 and a Z-score of +1. Still 68% of the data lies there. There is a calculation for finding your exact Z-score. So your Z-score doesn't have to be a perfect whole number. Your Z-score can be any value between 0 and 1. It could be 0.55 or 1.02 or 2.89. So Z-scores aren't exactly whole numbers, and they're found using the formula. Take the score that you've got, subtract the mean, and divide it by the standard deviation. Gives you the number of standard deviations in that distance. Let's have a look at the example. So again, you need to take your highlighter and highlight the important pieces of information. The measured amounts of milk in 600 ml cartons were found to be normally distributed. That's really important. Normally distributed. With a mean of 600. On average, they've got 600, but they have a standard deviation of 5 ml. What does that actually mean? It means that there are some cartons of milk that actually have 605 mils in them, or somewhere between 600 and 605, up to 610, up to 615. There are very few cartons that have more than 615 mils of milk in them. Likewise, there are some cartons of milk that have only 595 mils of milk. Down to 590, down to 585, then a very, very small percentage have less than 585 mils. You would hope that you weren't buying a carton of milk that had 15 mils, 3 standard deviations less than it should. I'm going to draw up the normal curve and put that data on it. So I suggest you pause this video now and do the same. So you can see there that I've drawn the normal curve, I've put my mean in, used the information about 1 standard deviation being 5, and should have highlighted that actually, standard deviation being 5 mil. So rather than, or not only have I got my actual quantities of milk, I've got my Z-scores. A Z-score of 1 gives us 605 mils of milk. A Z-score of 2 gives us 610. You can probably guess there are some results between 605 mil and 610 mil, and they would have Z-scores between 1 and 2. Likewise, between 610 and 615, very few cartons have milk over 615 mil. And you can see now I've completed the other side of my normal curve with both Z-scores at -1, -2 and -3, keeping in mind that Z-scores don't have to be whole numbers. We can see that at -1 there would be 595 mils of milk, but it could be possible to have 598. And if you had 598 mils of milk in the carton, then you've got a Z-score between 0 and -1 in between there. Okay. A. Calculate the Z-score for the following amounts. So the Z-score, we were told, you can find using Z is equal to the score minus the mean over the standard deviation. So in part 1, our actual score is 610. 610, take away 600. What do you know about 610? It's more than the average. It's above the average. If you're above the mean, you'll have a positive Z-score. And I can see when I do 610, take away 600, it's a positive number. All over 5. So it is a difference of +10 over 5, which gives me 2. So the Z-score for, SCORE, 610 mils is a Z-score of +2. In part 2, we're looking at a Z-score for 596. Already, you know that your Z-score has to be a negative because this value is below the mean. Let's write the formula, or please write the formula. which is the score minus the mean all over the standard deviation. The score in this case is 596, take away 600. When we do that calculation, we're going to get a negative, and the standard deviation is 5. And this is where the new calculator really is helpful, because I've not needed any brackets. I've put the numbers in as they appear in my calculation. I've pressed equals. I've got the negative, which I was expecting, and all we need to do then is convert fraction to decimal. And so you can see it's negative 0.8. Does that seem reasonable to us? Yes, at 596, it's only just on the right-hand side of -1, and of course the z-scores between in that range, 595 to 600, are these negative decimals, less than 1. So it seems very reasonable. In part B, you're being asked to find what amount of milk. Well, these are the amounts of milk. Anything less than 600, down to about 585, up to 615. So we're expecting an answer between that range. Has a z-score of 1.5. So if it's got a z-score of 1.5, we know it's got a positive z-score, it's going to have more than 600 mils. You can calculate this using the equation that the z-score is the number, and we're finding that x, the amount of milk, minus 600 all on 5. We could create an equation and solve it, or we think about what it means to have a z-score of 1.5. We know the amount of milk will be the average, because it's a plus 1.5. So we want to add on 1.5 lots of a standard deviation, which is 5 mil. So you can either find the amount of milk using your understanding of what the z-score means, or you can use the equation, substitute your values in, and solve your equation. And you can see then when you do that calculation, you get 607.5. Does that sound reasonable? Well, we're here between 1 and 2 standard deviations at 1.5. So we're expecting a number between 605 and 610. And yes, that's what we got. So part 2 tells you you've got a z-score of negative 2.6. So we're somewhere between -2 and -3. So we know that the answer should be somewhere between 585 and 590. In this solution, I've used the equation, and so I've put my z-score of minus 2.6 in, used the equation, filled in the values I know, which are the mean and the standard deviation. I multiplied both sides by 5. And that's where this comes from. And then I brought the minus 600 over and added it, and I got 587, which I'd be very happy with because it is between 585 and 590. Finally, part C is back to the percentage. What percentage of cartons have less than 500 mil? So we're here at 500. So we want to know the individual percentage there, and we add them. So that's our 0.15 and our 2.35, which add to give 0.5.